Today's topic is scientific measurement, and I want to start with this really cute comic. So let's go ahead and let's look at it. Okay, here's the play. Go out 10 meters, then cut left 5 meters. Meters? Jason, this is football. Everything in football is measured in yards. Look. In order for me to get the ball to you at the right place, the right time, I'm going to need to do a whole bunch of trajectory and motion calculations in my head. Trust me, it's a lot easier using the metric system. I'm telling you, you can't play football with meters. It's weird. Fine. Go out 10.936133 yards, then cut left 5.4680665 yards. Tell you what, let's stick with meters. So if you can't tell already, we're going to talk about the metric system today because that is what we use in science class. So why exactly do scientists use a standard measurement system? They do that to share information or to repeat experiments done by other scientists. Modern scientists use a version of the metric system that's called the International System of Units, SI. And you'll notice that International System and SI are reversed because it's actually French, Système International. So the metric system is a standard measurement system based on the number 10. Mass, length, and volume are all measured using SI units. And the great thing about this is all the SI units are going to have the same prefixes. So we're basing it on the number 10, and we're going to use all the same prefixes for mass, length, and volume. The SI units of measure that you have to know are length is a meter, mass is a gram, volume is a liter, time is second, and temperature, the actual SI unit is Kelvin, but that's reserved for laboratory settings, and so we're going to use Celsius within our lab, no Fahrenheit in class. Okay, so I know you've talked about the metric system before, but we're going to be discussing it in a little bit of detail, starting with kilo and going all the way down to milli. Our base unit right here is meter, liter, gram. To convert to a larger unit, you're going to move your decimal place to the left. So if this is a meter, we want to go to kilometers, we're going to go to the left. And we want to go to a smaller unit, then we are going to move to the right or multiply. So let's say we want to go from a gram to a milligram, we would move our decimal place to the right. Okay, so focusing on length in particular, the distance from one point to another is the definition of length. And the basic unit, SI unit, is the meter, and that's the base unit. So we're going to use a metric ruler, obviously. Some general conversions that you should know is that 1 kilometer, km, is equal to 1,000 meters. It's because of the stairs, they're 3 apart. 1 meter is equal to 100 centimeters. 1 meter is equal to 1,000 millimeters, and 1 centimeter is equal to 10 millimeters. Now, if I asked you to measure the distance of this the length of this leaf, what you would do is, as you can see, it's up to a centimeter ruler, and we have 5.5678, so 5.8 centimeters. Okay, so we're going to talk about mass. Mass is the measure of the amount of matter in an object. The basic SI unit is a kilogram, although in class we will use gram more times than not, because that is what our triple beam balance is going to measure. We will also use milligrams, and this right here is a triple beam balance. We're going to go to this game in just a second and practice some measurements, but first make sure you write down these conversions here, where 1 kilogram is equal to 1,000 grams and 1 gram is equal to 1,000 milligrams. Okay, so we're going to play this game, where we can practice reading a triple beam balance. And in this exercise, the computer will select a random weight and set 3 scales to that value. You have to read the scale and enter the value in the box right here. All right, so let's try one. Okay, so we have the way you read this is you're going to read the middle first, and then you're going to read the tens place, and then you're going to read the ones place, and that's where you'll have your decimals. So right here we have 500 plus 90 plus 4, but it's not a whole number because it's between 4 and 5. So 4.123. So 594.3 should be our correct answer. Let's check the answer. All right, so 594.29 is what they said it is, but they gave us credit because I rounded up. Okay, let's try one more. Okay, so in the hundreds spot, there's nothing. On the tens place, we have 40. Okay, so let's put a 4. And then coming down to the ones place, we have it's in between 6 and 7. So 546 points. All right, here's the 5 mark. 1, 2, 3, 4. I'm going to say 0.9. And let's check the weight. All right, good. So that's an example of how you measure using the triple beam balance. Okay, so we're talking volume now, and volume is the amount of space taken up by an object or a substance. The basic SI unit is the cubic meter, M3, or M cubed, sorry, but we use liter and cubic centimeter because cubic meter is pretty big. Think about a meter stick being what we use in class sometimes. Meter stick is pretty big, so a cubic meter would be quite a large box. So in class we use the liter or milliliter more often than not, and cubic centimeter if we're measuring a solid. And so liters are for liquids, cubic centimeters are for solids. Again, here's some information for you to write down. 1 meter cubed is equal to 1 million centimeters cubed. And we have 1 centimeter cubed is equal to a milliliter. This is very important for you to know. 1 liter is equal to 1,000 milliliters, and 1 liter is also equal to 1,000 centimeters cubed. In this classroom, you're going to measure volume using a graduated cylinder, and the way you read the graduated cylinder is you read along the meniscus, which is the curved line, and you have to read the meniscus from the bottom. So we would read this as 40, let me erase that. Here's 40, 1, 2, 3, 4, 5. So this is 45 milliliters. A property of matter that you're going to have to consider when dealing with everything is density. We're going to be talking about water very soon, and the density of water is 1. So we compare a lot of things to water, and density is definitely one of those things. And the measure of how much, so density is the measure of how much mass in a is contained in a given volume. So how much mass is contained in a given volume. The SI unit for density is a kilogram per cubic meter, the kg m cubed, but we use grams per milliliter for a liquid. Okay, this is just for liquids. And then we use grams per cubic centimeter for solids. And go ahead and document that on your note sheet as well, so that you know this one is for liquids and this one is for solids. Density has a formula, and it is mass divided by volume, D equals M over V. But I tell you to remember density equals love. And the reason being is if you draw a heart on your paper, go ahead and draw a heart, and then draw a line through that heart, you will see you have your M with the top part, and the V is the bottom part. So you have mass divided by volume when you draw a heart. So density equals love. You may not think about it, but time, it has an SI unit as well, and it's seconds. We can divide that into smaller units, which is milliseconds, and we use a stopwatch or a clock. You can use cell phones to record time, but we're going to, in class, we're going to use seconds. So I have a problem here for you. Jessica swims the last race in 22.56 seconds. By how much time did she lose the race? So this was Jessica's time right here, 22.40. So all you have to do is a simple subtraction problem. 22.56 seconds was the time that she swam the race, and 22.40 was the time of the first person, or the person who ended up winning. So she lost the race by 0.16 seconds, not even a whole second. But again, this is just to remind you that in science, in biology, ecology, we are going to use seconds if we are recording time. All right, so temperature is the measure of the energy of motion of the particles that are in a substance. When these particles move really fast, they're going to be hot, 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 hot. And when they are slow, they are going to be cold. So the faster something moves, the hotter it is. So think about gases. Gases move all over the place. When water boils, you've got your bubbles everywhere. And when water freezes because it's cold, there's not any movement because it's solid. At least there's movement on a molecular level, but none that you can see. So obviously we take a measurement using a thermometer. The SI unit is a Kelvin, but again, scientists use Celsius, and that's what we're going to use in lab. Some conversions you need to know is that 0 Celsius is 273 Kelvin, and 100 Celsius is 373 Kelvin. And absolute zero, just something you can put off to the side, is negative 273 Kelvin. So absolute zero is negative 273 Kelvin. So in science classes, you have instances where the numbers are so small and so big that we don't want to write the whole word out, the whole number out, not word. We don't want to write the whole number out because there's so many zeros, it's just ridiculous. So scientists, we'd like to take shorthand and take shortcuts as much as possible. So what we do is we use scientific notation. And there's kind of a format that you use, and it's A times 10 to the n. A is your coefficient, and it's always going to be between 1 and 10. So you'll never have a number that is above 10 as your coefficient. If that's the case, you're doing it wrong. And n is going to be your exponent. So let's go ahead and look at an example. Okay, so the exponent is going to tell you how many spaces that you're going to move your decimal. Don't forget that. If you have positive exponents, you're moving it to the right. So right here, we have 3.14 times 10 to the 5th. So this is a positive number, so that means we're going to move it to the right. So what we would do is move our decimal 1, 2, 3, 4, 5, and you'd fill this in with zeros, 1, 2, 3, 4, and this is, let's see, 1, 2, 1, 2, 3. So this is where this comes from. This is the answer. 314000 is the standard notation for that number. If you want to test yourself, you just put your decimal there, and then go back and see how many spaces you had to move. 1, 2, 3, 4, 5. You had to move 5 spaces to get to 3.14. And as you can see, this number is no longer larger than 10, so your coefficient is correct. Now, what if you have a negative number, 3.14 times 10 to the negative 5th? You have to move that to the left. So negative ones are going to go to the left. So right here, you'd go 1, 2, 3, 4, 5. Put your decimal there, fill it with zeros, which is what we did here. And then you can test yourself again by moving 1, 2, 3, 4, 5, and put your decimal there, and you get the same number, 3.14, 3.14. So 3.14 times 10 to the negative 5th is actually 0.0000314. And 3.14 times 10 to the 5th is actually 314000. So it's much easier to write in scientific notation, and there will be times where we will use it in class. Okay, so from time to time, we need to convert from one set of units to another. And the way we do this in science is through what's called dimensional analysis. Dimensional analysis works when a conversion factor or a fraction equal to 1, you're always just multiplying it by whatever it is. It's going to end up being 1. So 4 over 4 is 1. You'll come up with a fraction that will show you that you're going to cross things out until you get to the desired unit that you need. So here's a really simple example. How many centimeters are in 2 feet? Well, what you need to know is you need to always start with what you have. Okay, so list out what you have to start with. You have 2 feet. Okay, so there's your 2 feet. And then you want to list what you need to end with. And according to this problem, you need to end with centimeters. Let's try that again. You need to end with centimeters. So what we're going to do is we're going to convert using this process. We're going to convert feet into centimeters. And the way you do that is you know that there are 12 inches in 1 foot. Okay. And we can cross feet out. All right, so feet and feet, because we just multiplied this by 1 because 12 inches is in a foot. So that's basically multiplying it by 1. We haven't changed anything, but you'll notice we no longer have feet as our answer, as our unit. Now we would multiply 2 times 12 and we would see that be in inches. But we don't want our answer to be in inches. We want our answer to be in centimeters. So that means we're not done yet. So you would multiply it by whatever it is that's going to give you inches and convert that to centimeters. And there are 2.54 centimeters in 1 inch. Okay, so that now we can cross that out. Inches and inches cross out. And you would multiply this whole thing together, 2 times 12 times 2.4, because as you can see, now your unit is in centimeters, which gives you an answer of 60.96 centimeters. Or you could just simply round up to 61 if that was acceptable for the worksheet or problem or whatever it is that we were working on.